I just remember.
And then that one, don't multiply it by this.
Hi, sorry, Professor. We had a question.
yeah.
On the 2022 final exam,
Okay.
question 6B, it's this question.
I don't know if this
Is that visible?
Yeah, it is visible, yeah.
You're wondering, why the runtime complexity, like in the solution, it said initialize ij and sum to 100. We're wondering why the complexity is log of n rather than just n.
It's log of n rather than just n. So the outer loop runs log n time, right? Log n times, right? Because you're multiplying I by 2 every time. Does that make sense?
Yeah.
And then if you notice, the inner loop does run the inner loop runs basically the j never gets reset.
Yeah.
Right. So what that means is that it's gonna it's gonna run like how many times. So the first time it's gonna run 0 times. The second time it's gonna run up until 1. The third time it's gonna run up until 4 and so on. So until the inner loop is gonna run n times.
we were wondering though, why you were thinking it's n because
Yeah.
notice that the outer while loop is sort of like a check. Like the inner one runs up until I equals n over 2, and the outer loop kind of like stops it. And that's like n over 2 plus n over 4 times plus. So we're thinking
Right. Yeah. So it's it is so the way it's set up here, it's the way it's set up here, it's O of n. Yeah.
so the whole thing is O of n.
Well, yeah, because just think about how many times does the innermost thing runs. And the answer is it basically like j never resets, right? And j advances by 1 every time. And eventually j is going to become n.
So like the outer one's kind of like just a check, and the inner one is what.
Well, it's not so much a check. It's that so it could potentially be different if it were to reset every time, but it doesn't reset every time. So it could be that that would still be O of n, but it could be like 1 plus 2 plus 4 and so on.
So if
plus 8, that would still be O of n as it happens, but
if j were to reset, would the time complexity
still O of n. So still O of n, but for a different reason, right? So if it were to reset, it would be like 1 plus 2 plus 4 plus 8 and so on plus 2 to the log to n.
Okay, thank you.
Does that make sense?
Wait, plus 2.
So let me write that. Yeah, I feel like I was maybe like too quick as well because maybe well, I guess everyone saw it on the screen, but maybe just like doing it by voice is not perfect. Sorry, I'm just sorry, remind me, this is 2022
Question 6B. Or 6, yeah, 6B.
Yeah, 6B.
Yeah, sorry, I should have like done it on the screen from the beginning. So wait, it's the midterm.
Not the final. Bye bye.
Yeah. It's fine. Oh,
Like Jack.
okay. So the way to approach this is to say, okay, how many times does this run, right? And the answer to how many times does this run is to just say, well, it's going to run once for j equals 0, and then another time for j equals 1, and another time for j equals 2, and another time for j equals 3, and so on up to j equals n minus 1. Right? And that's because j never resets, and eventually I is going to be n minus 1, n minus 2. Yeah. So eventually j is going to go up to n minus 2. Does that make sense? So for that reason, this runs all of n times. So you also want to make sure that like nothing else runs like for more times, but it doesn't, right? So the outer loop runs for log 2n times. Right, so that's fine. So the inner loop is what's important because that's what repeats the most amount of times, and that's all of n. So the question then was, well, like, suppose it wasn't like this. Suppose we did reset the j, right? Does that make sense? So with so either way. That makes sense.
Yeah, that makes sense. Want to ask the divide by 3 if it makes log base 3.
Which divided by 3 one?
We had one more question, if that's okay. The same question 6 part C, when you return with G and then N integer division of 2, it like that makes it like 3 to the log base 2 of N. But is there a case where if you did like N divided by 3, would that make it 3 to the log base 3, or is that not how it works?
Yeah, so this one is kind of complicated. So yeah, like the math would be like that, yeah. So it's the same kind of logic, right? So yeah, it is, you know, the same logic.
Thank you.
Thanks.
I have a question on how to determine like the complexity of the selection sort function.
Okay.
So like, do you like I feel like my understanding right now is you find the complexity of like the outer loop and then you multiply it with the complexity of the inner loop?
So that is sometimes true, but not, but that only works if the runtime of the inner loop is constant, right? So in situations where the runtime of the inner loop is not constant, that's not guaranteed to work, right? So
So like for selection sort, you
yeah, so
basically, sorry,
yeah, go ahead.
you basically do two for loops and then you call the outer one like n times and then
Well, so like the issue is that it's not so it doesn't work like that because this doesn't run a constant amount of times,
right.
right? So that means that, you know, like, so what is true is that if you do something like this, then this would run
Times m.
yeah, and times m times, yeah. So that's true, right? But there is no m over here, right? Because
Right.
this is like a different one. I want to do it like the way we've done it. So here we are starting from 0 and going up to length of L minus I, right? So that means that for different I, so for I equals 0, this runs n times. And then for I equals 1, this runs n minus 1 times.
Mhm.
Then for I equals 2, it runs n minus 2 times, right?
Yeah.
So that means that the total amount of times is like this. And this is just, you know, like 1 plus 2 and so on, plus n is just the formula.
But doesn't the outer loop always run n times?
The outer loop, yeah.
So why don't you consider that? Like, why do you only consider the inner one?
So the reason is that basically we could consider that and it wouldn't matter because it's true that the outer loop runs some amount of times, but by its very nature, the inner loop runs more times. And what we want, so like you could say, like, what about this? And it's true, like this part runs n times, right? It's just that this is going to run a lot fewer times than this. So how many times this runs is just more important, if that makes sense.
Yeah, that makes sense. But like, so like for I is equal to 0,
Maybe
then
you're
it-
asking about like in the computation, why don't they consider it?
yeah, maybe.
Right. And the reason I don't consider it in the computation is I don't consider how many times like, so maybe you're asking like, why am I just like counting the number of times that the inner loop runs here, right? And the answer is the question that I'm trying, so I know that this runs n times. And then I know that this runs at least 10 times. It runs more times. So for convenience, I'm just counting up how many times does this run. Is that making sense? I don't know.
Still a bit confused. Sorry.
Okay, so So what are we trying to do here? We're trying to say, what's the runtime of this function proportional to, right?
Yes.
So then we're saying, okay, so some of the stuff in this function is going to run as many times as the outer loop runs, right? So it's going to be this line, and it's also going to be this line, right?
Yeah.
So when we're doing our counting, we're going to say, well, the total amount of the total runtime. So we did this argument like the once, and then we kind of dropped it because don't want to do it every time. It's like line 3 runtime plus line 8 runtime times n, right?
Yeah. That's
And
outer,
then,
right?
well, that's like those lines which run n times.
Okay.
And then we're saying, okay, what else is going on there? Well, the other things that are going on is lines 6 and 7, right? Playing a little bit fastest loop with 5, or fastest loop with 5, but okay. So line 6 and 7, right? Right? So here, what we've proven with the math here is that the number of times that line 6 and 7 run is n squared, approximately, right?
Why wouldn't it run n minus like I'm confused with like why the first one is like n and then the second one is like n minus I guess.
So you mean like this one? So the first one is n because we're saying for I in range length of L, right? So this is definitely going to run
N
length of
times.
L times, and so n
Yes.
times, right?
Mm-hmm.
This one is not like that because it's gonna run n times the ones, and then when I is equal to 1, it's going to run n minus 1 times. And then when I is equal to 2, it's going to run n minus 2 times, and so on.
Oh, okay. So like the n minus 1 and the n minus 2 incorporates the outer one running, right?
So it doesn't exactly incorporate it. It's just so kind of in math terms, it would be like dominates, right? Because it's definitely the case that this runs just more times than this.
Okay, yeah.
Right? Because
Yeah.
it's gonna run, like at least once every time that this runs, this runs
Yeah.
multiple times.
Okay, that makes sense. So like for future complexity problems, do I always look at the loop that runs the most and then do the complexity of that?
So yes. The one subtlety there would be that in some situations you have loops that are not explicit in the code. So that was the example with counting sort, right? So with counting sort, we had computations like max of L, right?
Right.
And in order to compute max of L, you have to go through the entire list L. So max of L, implicitly, it's a loop that kind of goes through L and tries to find the largest element in L,
Okay.
right? So that's kind of what makes it distinct.
Okay.
So you might have a situation like, you know, so this would be all of n squared because here you're like every time inside this loop, you're computing you're computing an operation that has to take at least a time that's proportional to n.
So this one would be n squared?
That's right.
Okay. Okay, thank you.
Yeah. Yeah, David.
Hi, Professor. I just have a question about like Max Allen, etc. Like for functions that are like that we can use from Java, are we expected to know the time complexities of these functions, or will you give us
Functions from Java, what?
like sorry, Python. Sorry, like for
s-
example, like Max Allen, are we just supposed to know that the time complexity of it is n squared or
No, the time complexity of it is not n squared, it's n, right?
like yeah.
So uh, I would say that nothing that did not come up in lecture you would be required to know. So if something comes up that wasn't in lecture, I would explicitly write it on the exam.
Okay, so like for like Max Allen, then I guess we're supposed to know it.
Yeah.
Okay, all right, thank you. And then I do have another question.
Like it's also like nothing there is like not common sense, right? So like just
Okay.
yeah.
Yeah, I got it. Thank you. And I just had a question about so on the 2022 exam, I saw there was like a reference sheet at the bottom of the exam.
Yeah, it's the same one that's posted for for the past exams. It's always the same. Yeah.
Okay, all right. Okay. So we'll have access to that then.
Yeah.
Okay, all right. That's all I have to ask. Thank you.
Great. Yeah. Yeah, Allison, I'm not sure if the hand is up from before or it's a new question.
I had a question
Oh, okay.
about just the call trees in general.
Mhm.
Like how do you, and also the arithmetic sequences, how would
Okay.
you incorporate those formulas with the call trees
Trying to think of an
for
example.
recursion?
Yeah, I understand. So I'm not sure we had an example where we had done that. I guess we did with it. Yeah. No. No, so we had geometric, but I don't think we actually had arithmetic. It's not that easy to make it, like a geometric.
Will
So
that
like
be
I'll
on
do
the,
a geometric one if that's okay.
okay. Will that be
Unless
on the
you
exam?
remind me. Say again?
Will arithmetic be on the exam?
I mean, sorry, so like we have just done an example from lecture that had an arithmetic series.
Okay. Yeah.
It's just that I'm not saying it's not possible to come up with an example that kind of combines cold trees with the arithmetic series, but it wouldn't be like a natural example.
Okay. Could you go over geometric then?
Yeah.
Okay. Thank you.
So what does the cold tree here look like? So you call power to n. And then you call, power 2 n minus 1, power 2 n minus 1. So why is that like that? So in order to compute power to n, you need to compute power to n minus 1, and then again compute power to n minus 1. It so happens that they are the same, but Python doesn't know that, right? So in order to compute this one, again, you need to compute power 2n minus 2. And this one is like also power 2n minus 2. And this one is power 2n minus 2. And this one is power 2n minus 2. And this creates like more calls and so on. Right?
Yeah.
So then and then eventually it's all like 0 things. So the question becomes, okay, how many calls is that in total? Well, and the trick we use is we compute that level by level. So we say there is one call here, and there are 2 calls here, and there are 4 calls here, and so on. And that's because this call spawns this guy and this guy. And then this call spawns this guy and this guy. So every call spawns 2 more. So there is like twice as many here as here, and there's twice as many here as here. And then there is twice as many here again, and so on. Right?
Yeah, this makes sense.
Okay,
But how would you find the runtime?
I'm getting to
like-
that. Yeah.
Okay.
So now we're saying how many calls are there in total? And this is going to be like 1 plus 2 plus 4, and so on, plus how many? Well, 2 to the n. Right? And that is because how many steps to get from n to 0? Well, n steps, right? So you go 2 to the 0, which is 1, plus 2 to the 1, plus 2 to the 2, and so on, plus 2 to the n. So here, let me make it better. So we have 1 call on this level, 2 calls on this level, 4 calls on this level, 8 calls on this level, and so on, right? So the sum total of the number of calls is going to be this. So here it would be 2 minus 1 according to the formula, right? So the formula is this is the formula, right? And that is just equal to 2 times 2 to the n minus 1. Okay, so this is how many calls. And then if every call takes the same amount of time, then it must mean that the runtime is proportional to 2 to the n.
Right.
Yeah, I
How Sorry, I still don't really understand how the geometric formula turns into like 2 to the n. Would that just be like what it's equal to?
This is the formula. And here it's that r is equal to 2.
Yeah. So then oh, okay. So then it's just 2 to the n for runtime? And is it always the case that when you have recursion, you want to make the call tree first? and then you sum up the total number of calls and then put it into a geometric formula, or
No. It's not always the case. Now, if there is a formula at the end, then it likely would involve a geometric series. Just because like it's usually the case that each call spawns some other number of calls. And that means you're like multiplying by a constant at every level. But if you look back at the merge sort example, it can be more complicated than that, right? So with the merge sort example, what we saw was a situation where it wasn't the case that every call took the same amount of time. So we had to do kind of a further trick in order to be able to actually make the kind of make a computation that produces a formula.
also for merge sort in lecture last Monday, I think you mentioned that merge sort won't be on the exam. Is that so true?
Yeah. So I didn't say merge sort wouldn't be. I said the analysis of merge sort for runtime complexity.
Okay. 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 That makes sense. Yeah.
Yeah, David.
I'm actually a bit confused on like I don't know if this would be like on the exam, but like what happens if like how will we analyze it if like for example like the runtime of each like power function is like there's another for like let's say it's not a power function, it's like a different function, but like it has an extra loop in it, a for loop, which goes from 0 to
So that's the situation with merge sort, for example, right? And the trick with merge sort was that kind of by a happy coincidence, we were able to sum up the runtimes for all the calls on each level so that it worked out. But there's no guarantee, of course, that you'd be able to, like, for some things, there are no formulas. Like it just runs for whatever amount of time it runs, right?
Yeah, okay. Then I guess since like the analysis of like merge sort wouldn't be on the exam, what would that mean like similar analysis to merge sort would be on the exam or if there was another for loop in like let's say the power function.
I mean, like I'm not going to be unreasonable about it. At the same time, I'm not going to like exclude categories of things, right? So the distinction is between things that people are supposed to know versus things that people are not supposed to know. But like plenty of problems on the exams are like their problems. You're supposed to solve them, right?
Yeah.
So it's kind of like that.
Okay.
So yeah, and I like honestly like I don't have a wouldn't have a problem answering this question in particular. It's just that like if I start getting into like like this entire category is excluded, people are like it's never going to end. Like people are going to keep asking.
Yeah, that's understandable. I just have a question about like the exams, like the format, because I saw like the format of the exams each year is like really different.
I disagree with that. The 2021 was different because it was done during COVID, but the other like do you mean like the recent ones? Like can you point to kind of something specific?
Oh, yeah. Wait, sorry, I have too many tabs open. Um, I didn't really look past the 2020 exam. I think it's all right then. I'll just like
if it was about the 2020, then that's because
yeah, that one I got really confused on because it was just a text file.
Yeah.
Yeah, thank you.
Yeah. So it's definitely the case that like if you look for like at exams that it wasn't me who wrote them, then yeah, like they can be different. But mine,
Okay.
I think were actually pretty consistent, except for 2020. And the reason it was different in 2020 is just that it was done kind of offline, so it's online rather. So that was a completely different thing. Yeah.
I got it. Okay, so it'd be more similar to the 2022 one then.
Yeah, like all of them. Yeah. So there's like 7 or something. Yeah.
Wait, sorry. I couldn't really find the other ones other than like anything like in the 2016.
Well, yeah.
Yeah, I only saw like the last one because I only see the 20 on the your website, right? The course website.
Yeah.
I only see 2022, 2020, and then 2016, which
Yeah.
2016 probably wasn't by you, correct?
It was big.
Oh, it was by, oh, okay. I got it. Yeah, because I was just wondering because 2016 had 10 questions, and then 2022 had 7 questions, I believe.
That's like normal variation.
Oh, okay. All right. Okay. Thank you.
Yeah. Yeah, Allison, you have your hand up, or maybe from before. I'm not sure.
No, I have some questions.
Okay.
Did we only do 3 sorting methods? Like
Um,
merge and counting and
merge,
selection?
counting, selection. Yes, that sounds right. Yeah.
Okay. And also, I have a question about the memory table. So like for the the worksheet that you gave us, you like split it into like the memory table and then also like the global variables. And then you said that like it's my understanding that you never change the global the global variable table, but you only change the memory table.
No, that's not right. Sorry. So
Okay.
so I think what you're thinking of possibly is that when you are assigning to a variable. So like if it's like variable name equals whatever. So that would never change the memory table. Right.
So like if I had a list, sorry. If I had a list that was like L
that
is
doesn't matter. So like the only thing is of course like if like the right hand side like implicitly changes something, then yeah. But other than that, or like puts a new thing in memory. Well, let me. So on the other hand, like var name at x or something always writes to the memory table. I don't want to say changes because like if you're assigning the same thing to something that was already there, then no. But this is going into the memory table and it's changing, you know, a list or a dictionary or something like that. That's changing it. That's changing a variable. A memory, a value in the memory table. Sorry. This changes a variable table.
so if I had like a list and like in the global variable table, I'll be like L is at say 1000. And then if I said list is equal to like a new list,
So it
would it still be to
it
at
would put
1000?
something new to the memory table, but it wouldn't alter existing entries in the memory table. So there is also kind of a separate thing that I want to emphasize here, which is like there is a global variable table and a local variable table. And this has to do with whether you're assigning to a local variable or a global variable. And that's separate from, are you changing the variable table or the memory table? So right now we're talking about, are we changing the variable table or the memory table? So kind of the rule of thumb is this always changes the variable table or writes to the variable table, because you're saying, take the right-hand side and make it so that this thing in the variable table is something potentially new. This is always going into the memory table because you're going to a particular element of a list or a dictionary, which is in the memory table, and you're writing to the memory table.
But like, would the location that the variable points to change?
So I think there's kind of like a lot of terminology here. If this is your global stable, let's say, and this is your memory table, and you're saying, and it's like 10, 12, 10, 12, 5. And you're saying something like a equals 5. What this does is it says that the variable a is going to refer to 10, 12. So this, and then if you say a equals 6, if this is like this, then a equals 6 makes it so that this used to be 10, 12, and now it's 10, 16. Okay, so this is the sense in which if you have just a name on the left-hand side, what changes is the variable table, not the memory table. So this is as opposed to having a list. Maybe it's also 5, 6 just for convenience.
Mm-hmm.
And then you're saying like LN0 is equal to 6. So this is going over here and changing this to 10, 16. Right, so that's
okay, yeah. That makes sense. And then if I said L at 0 is or like if I said L1 is equal to, sorry, like a new list, like a new variable, like L1 like is a copy of L, and then you set L1 to be equal to like a new list.
You can do that. And it doesn't matter like if it's a copy or not, actually. So you can do that, and that would mean that you're putting a new list in memory. So this would be like also 5, 6, right? And then you would and then once you've done that, you're saying this is like 10, 24.
L1, like it's a new list entirely. Like L1 is like a shallow copy of L.
L1. Okay.
Yeah, or
So
like X or something.
yeah. Yeah, so that would actually be the same thing, and then L1 is over here, and that's at 1024.
Point to the same location as L.
No, if it's a shallow copy, it's a copy. It's so it's not an alias.
Oh,
If
right.
you say L2 equals to L, that's an alias. So in that case, L2 is going to be at 1020.
Okay, that makes sense. And then what if you said L2 and then square brackets 0 is equal to square brackets of like 100, like a new list of 100.
Zero is equal to something new.
Square bracket, yeah, 100 or something.
Yeah. Yeah. So again, like you would create a new list that
Mhm.
so somewhere over here. That's something like this, and something like this would be 100. And then once you've created it, you can go to L2. So L2 is at 1020, and L2 at 0 is going to change to 1028.
Okay. So that would also change. That would also change L, like L.
Yes, because L2 and L are really the same thing.
So is there any way to change, like there's no way to change L2 without changing L if you make them aliases?
So there's no way to change the contents of L without changing the contents of L2 and vice versa. You can just like you can with integers, right? So like if you say like a equals 5, so new example. So if you say like a equals 5 and then you say like b equals a, and then you say b equals 6, that's completely fine, right?
Yeah.
And in the same way, if you say L equals to like the list 5, and then sure, and then you say like M equals 6, that's also completely fine. That works the way you would imagine it would work. So, and that's precisely because of what we discussed, right? Is that if you are doing something like this, what you're doing is you're changing the variable table, right? So you're saying M used to be the same with L as L, and now M is something new, right? So the issue arises when you're doing something like this, or indeed something like this, and then you go and you change the contents of the list, where when L2 and L are really the same list, if you change the contents of one, you also change the contents of the other. The distinction here is if you just say M used to be the same as L, but now I want the whole of M to be something new, that's completely fine. That's what that results in what you would expect, which is that L is still 5 and M is now 6.
So it only, like you can only change the entire thing and change the location that M, like the address that M points to if you
Yeah.
change the entire thing. Okay.
So more like what you can do is you can say L used to refer to one, or whatever, like
Yeah.
M used to refer to one address, and now I want it to refer to another address. That you can always do, and you can do it with lists in the same way that you can do it with integers. So what's special about lists is you can change the contents.
Right. Okay, that makes sense. Okay. I also have another question, but if Emily has a question, then she can ask it.
I just had a question about deep copy. For deep copy, would you always have to call the deep copy function, or?
I mean, so we have done kind of a manual sort of deep copy for a list that has a structure that we know, right? So if you know the structure, then you could say, like copy, it's this, and then, yeah, or you like this. So, and you can do this because if you know that that's specifically a list of integers, then that can work.
Wouldn't this be a shallow instance?
No, so
It's
that would be a deep copy, right? And that's a deep copy because we're making a copy of each of the sublists, and then you cannot go deeper in that particular case.
Oh, okay. And a shallow copy would just be if you copied the list itself and appending every element, so like not the sublist.
Yeah, that's one. Yeah.
Oh, okay.
Well, for example, yes.
Yeah, that would be a shallow copy.
That's right.
Okay, that makes sense. Thank you.
I was wondering if you could explain the call tree for merge sort.
You know that that's not in the exam though.
Yeah, but like in
Okay.
general, I
Yeah.
don't get it.
So basically, or where's my merge sort? So basically, what do we do here? So merge sort creates two calls, so one to the first half of the list and one to the second half of the list, right?
Mm-hmm.
So the notation here is like this is a list of length n, and then this is a length of length n minus n over 2, n over 2, and so on, right?
Mm-hmm.
So each call spawns two calls, each of size, half of the original list.
Right.
So that's the call tree, right? It's like a list of length n makes two calls, n over 2 and n over 2. Each of those makes two calls, n over 4 and n over 4, and so on.
Mm-hmm. But doesn't that look, sorry,
Go ahead.
doesn't that look really similar to the one above?
It does.
The
It does, but the difference is that here what we're doing is actually what's the one above?
the other document
Okay.
of all
Yeah.
the
So
merge.
yeah. Well, it has several
Right.
similar ones. The difference to this one, first of all, it's not less, but also we are going in steps of -1 rather than over 2.
Mm-hmm.
So that makes it so that there is a lot more calls.
Mm-hmm.
So the computation here is like 1 plus 2 plus 4, and that's the same, if you wanted to count the number of calls, that would be the same pattern, except we go up to 2 to the n rather than up to 2 to the log n. And that's because here there is
Right.
n steps in order to get to the top of the tree, whereas with merge sort, there is log to n steps because we're halving every time rather than subtracting 1 every time. So it is the same as this one, right? So if we
Yeah.
wanted the number of calls in merge sort, that's exactly the same computation as the number of calls in some list. The
Like log
difference,
2n.
well, 2 to the power of log 2n, yeah. So the difference is that here every call takes the same amount of time, right? So here all we need to do inside the call is just do this plus. But in merge sort, what we're doing is we are calling merge inside the call as well, right? So here inside the call, we are doing this work, but we're also doing work that's proportional to the length of the list.
Is merge a different function?
Yes, it's this one.
Oh.
Okay.
So you're taking the complexity of the inner function of merge sort and then putting it into
Not exactly. So you need to do a trick in order to make it work, right? So here the trick was that we said, okay, like the runtime of the call is proportional to the size of the list. And then it so happens by luck that if we compute the sum here plus the sum here plus the sum here and so on, so the sum here is proportional to n, and the sum here is proportional to n because it's like n over 2 plus n over 2, and the sum here is proportional to n because it's n over 4 plus n over 4 plus n over 4 plus n over 4, and so on. So we can say that on each level, the runtime is proportional to n, and we have approximately log to n levels. So in all, the runtime is proportional to n log to n.
Oh, okay.
That was like a complicated argument.
And it's just like from like, I don't know, experimentation that you found this thing?
I mean, I don't know, to be honest, that they found it. I remember like writing it down at some point, but I'm sure someone
Oh,
told me
okay.
before.
Okay.
So like it's not yeah, like it's not so like I think what you're like the underlying question is like, like is this like easy to come up with? And the answer is no.
Oh, okay.
But at the same time, like all of those things, they kind of, or not all of them, but a lot of the ones that are solvable at all follow some kind of pattern. So like in the same way that like, like most like integrals in calculus, like nobody can compute, like they're not solvable except by like numerical methods. But for some of them you can follow a pattern and it kind of works. Technically for all the solvable ones, like there is an algorithm. It's just that that algorithm is like very difficult.
Right. Okay. And I have one more question, and it's like particular to my code though.
Okay. Do you want me to like stop the broadcast?
I don't really care.
Okay.
It's just,
All
could
right.
I share my
Yeah.
screen?
Yeah. Okay. Go ahead.
Okay.
Yeah. I need to like allow you to share. Oh yeah. You can share. Yeah.
Okay. So for
Sorry.
like
I just
this,
need to respond to an email for a second. Just 1 sec.
okay, sure, take your time.
Yeah. Go ahead.
Um, yeah, so I like made a sort function,
Mhm.
but like now that I look at it, it's like similar to the selection sort. But like I started with like going backwards first,
Okay.
I think. Yeah. Um, in this case, because I used like the min thing, would this be a complexity of O to the O of n cubed?
No, because you are only running min of L n times. So just like, like if you cut it off at line 91, it would be O of n squared.
Like cut it off?
Like if you just took like a function, it's not like a complete function, but you could still run it like from line 87 to line 91.
Oh, like just this?
Yeah. So this is O of n squared because you're running something that's proportional to n times.
Right. But then wouldn't this be another like O of n? So like together would
Well,
be
No, because it's additive, right? So if you're running something for a runtime that's proportional to n, and then on top of that, another thing that's also proportional to n, that's still proportional to n. It's like because like n plus n is 2. Oh, it's a little bit more complicated than that, but essentially like n plus n is 2n, right? So that's still proportional to n. So
Oh, okay.
so the multiplication happens if you are repeating something that's proportional to n times.
Okay.
Does
Okay.
that
Because
make sense?
yeah, because so like basically because these two are in the same like outer for loop.
I suppose that's one way of saying it. The way I would say it is they're like consecutive rather than nested.
Okay. Yeah, probably that's a better explanation. Okay. Um, yeah, that's basically it. Thank you.
Professor, I just had a quick question about what's the difference between linear mythic time and logarithmic time? And how would you determine that? Like,
I mean, so first of all, linear time, and maybe that will be a short question. So linear time means of n. And
right,
oh, hey Ronaldo, what are you doing here? Okay, never mind. Okay, so linear time means O of n, and logarithmic time means O of log n.
right,
So that's just like what those things mean. And then I don't think kind of the way to frame it is how would you tell the difference as much as like for a given program, what is the runtime? And then like it's hard to do because like we've done like like a week and a half of that, so it's hard to summarize. But essentially what I would suggest is just like looking through the examples, and like one thing you can look at is the summary of the different tree shapes for recursive functions that we did on the Monday on the last lecture on Monday.
right.
Uh,
I meant for like O and log of n and
oh, I see.
linear time.
Right. Yeah, right. So yeah, so that is like there is like it's not logarithmic there but yeah, so like so n log n, we really have only seen like one substantive example of that, which was merge sort. And that
Right.
wasn't like, so that's the analysis that we went through briefly, I think just a few minutes ago. And it's like not an easy analysis. It just turned out that that particular function turned out to be of n log n because of this, like not so easy proof. So the only other example of kind of something that's of n log n that you could probably come up with is just like an outer loop that runs n times and then an inner loop that runs log n times, and then you just like nest them, but like it's not like a usual situation. So in general, I mean, I would say usually, not always. Like sometimes something turns out to be linear time, not because it's just like a for I and range n, but like the paradigmatic example of a linear function is for I and range n, and definitely if it's like for I and range n, and then something that's constant time, that's definitely linear.
Okay. And could you go back to the deep copy example that you just did?
Okay.
I didn't write down.
I need to reshare.
And for that one, if you want to make a shallow copy, just
So this
slice
is
it
currently a
in the
shallow copy, and that
oh sorry, a deep
this is the
copy.
deep.
And
Yeah,
that would be the deep
yeah,
copy. Okay.
yeah.
Okay. Got it. Thank you.
Sorry, I have one more question. Well, it's not, yeah. I'm confused as how you would approach the 2022 exam question number 7 about like the friendship chain.
Yeah, we have it. So like that's not like okay. So like the way I wrote the solution, you can't really do it. We haven't really done that.
Oh,
The
okay.
alternative way of approaching it, which we have done, is to just think about, okay, like I want to generate all the possible chains of potential friends. And this is like generating all passwords. Right.
Oh, okay. Like
And
the
then
exec and eval thing?
yeah. And then once you've generated all the possible friendship chains, you just check whether it's a valid friendship chain and you find the shortest one.
Oh, okay. So this has like nothing to do with like the read text thing? Okay. Okay. Thank you. Have a